Hello and welcome back to a new video. In this video, we're going to be covering Go's map structure and all of the CRUD operations that we can do with it, meaning how to create a map, writing to the map, deleting from the map, and updating all sorts of stuff. I will also be taking this with an approach that you are brand new to programming. So the first chapter of this video is going to be geared towards setting up the problem for why we need maps, but you can go through the chapters listed down in the description of the video to skip ahead to all the different operations that we can perform on maps if you are more of an advanced programmer. Let's get right into it. Here's the problem. I want to create a program that tracks the addresses of all my friends. With the tools that we've learned so far up in the series, your first solution to this may be to create a variable for every name and address. So for instance, I would have p1 name equal to my name, and then I'd have to track the address, right? So I would do p1 adder and then put in the address. So 123 Fun Way. But then what if I needed to add another friend or wanted to track another friend in my program? Well, then I'll have to do a p2 name, so like Emily, and then p2 address, which is equal to some other address. And you can start to see the problem here. We have to continuously add variables to track the name and the address. So that's actually two different issues. One, continuously adding variables. The second is that we have to track two different variables per person, both the name and the address version of it. So this isn't really scalable, and honestly, once our program is compiled, it's impossible to continuously add any new variables to the program. So now your next solution might be to create two different slices, a name slice and then an address slice. And at each index will be the name of the person, and then the same index over in the address slice would be their address. So I'll go ahead and program that out for you real quick. So we could have a var names, and that would be a slice of string. And then we could have var addresses, which would also be of a string slice. And then every time that we are wanting to add a person and their address, we would have to call the append function. So we would do append and then pass in names, and we could do colon and make sure that you assign names equal to the append, and then something very similar for the addresses. So put in addresses here, and then it's 123 Fun Way or something like that, right? So this is also another issue because one of our slices could go out of sync. If let's say I added, Emily to this and then her address, but then I needed to delete the address when she's no longer my friend or something, but then I forget to delete her name in the other slice, we can start to see there's a big consistency issue here. So running two different, or maybe you'd say two symmetrical slices, is also not a way to solve this problem. Instead, we can use the concept of maps to help us map a key to a value, therefore creating a key value pair. The best way of thinking about maps and programming is using the analogy of a dictionary. When you want to go look into a dictionary, you first look for a word, right? So let's say that we go look for the word computer in the dictionary. Every word in the dictionary is considered a key, and then the key's value is its definition. So according to Google's definition of a computer, it's an electronic device for storing and processing data, so on and so forth. We can have the same exact thing going on in our programs. So let's get into the basics of maps. Let's start by learning how to declare a map. So it has the following format. We use the var keyword, just like for any other declaration, then use the name of the map, then we give the data type. So it's map, and then we use square brackets, and within the square brackets, it's going to be the keys data type. So we'll do type 1, and then after the square brackets, we then put in the value or the data type of the value in the map, so type 2. So in the vein of this problem of creating an address book, it would look something like this. So the var keyword, we'll call this variable the address book. It is of map type with the key or the name of the person being of type string, and then the address, which is also a string. Now maps do not need to be strings to strings. It can be strings to ints or ints to strings or characters, runes to strings or any other data type. But what matters is that the key type up here is a comparable value, meaning that usually needs to be a value type. So again, like I was saying, an int or a character string, and it cannot be another map that sits in here or a composite type that cannot be compared to another type. Now, just like any other data type that we have in Go, by just declaring the map, it has a default value, which is nil since it is a composite type. So if we do a format print line, we can do map equals nil, or sorry, not map, address book, save and run. We get that it is true. We can access a declared map if there is nothing in it, but we cannot write to the map. So if we try to do address book colon equals some empty string, we'll get a panic actually. So let's run this, and here we can see the panic. So we need to initialize the map before we can actually really do something with it. If we want to change this declaration into an initialization, just remove the var keyword like we have with all of our other variables that we've done. Use assignment/declaration initialization syntax here, and then you add curly braces at the end. So now if we go back and put in that format print line and do address book equals nil, we'll see that that is false. It's initialized to some value, but there's nothing within the map at the point of printing. But then there is something put into the map with this statement right here, but we'll get to that here soon. We want to initialize a map with initial values. All you have to do is just put in a comma separated list of keys and values within the braces. So here I can go ahead and put my name, then use a colon to divide the key and the value. So I'll do 1, 2, 3 fun way. And you might think that you can just end the statement right here if you just need a single initial value, but you have to put in a comma due to Go's formatting. And then this is a legal initialization of a map with initial values inside of it. To drive this point home, we can add in Emily and do some other address, and then just make sure there is a comma at the end, and then we can go ahead and print out what our map looks like now. And we see that this is a type map, and then there's a key, a value, then separated by a space, then we have another key and a value. On the topic of putting values into a map, let's go and talk about how to do that without doing the initialization syntax. So let's remove the initial values of the map here. And just like we have with slices, where we use this square bracket notation to insert a value at a particular position, it's just like that for maps. So if I want to, again, add myself into this, we use the address book variable name, and then with the square braces, we put in the key. So I would put in colon, and then we just assign it to another string. So 1, 2, 3 fun way. Save and go run this, and we get that the map just contains my name and the address. If we happen to insert into the map with a key that already exists, so let's copy this and put it down here. So I want to change my address and change it to some random string and print it out. We would get that it was overridden after that assignment. So there cannot be two keys in a map that are the same. Now, what if we want to access values in a map? Because so far we've only just been printing the entire map, so that's not very helpful except for in debugging purposes. So let's look at how we would access a particular value. Let's remove all of this, and if we want to access a value, it's as simple as just putting the map's variable name and then the key of the value that you're looking for. So let's wrap this in a format.print line, and as you can see, we've actually initialized the address book, but colon has never been inserted into this map yet. So what happens when we run this? We do a go run, and we get an empty string is printed out because that is the 0 value of string. So if a key does not exist in a map, you just get the 0 value returned. Now let's go ahead and initialize this map with an initial value in there. So colon, we'll do 1, 2, 3, 4, and I'll just type fun to be short. So now when I go to run the program, I get 1, 2, 3, 4 fun returned back to me. So in other languages, what happens is that if the key does not exist in the map, you get a null value, or in Go's terms, it would be nil. But in here, you're getting back the 0 value for strings, because strings are value types. But had I put in a struct or something else, then we probably would have gotten back nil. When it comes to accessing values in Go in a map, there's something called the OK idiom. So let's extract this access right here and assign it to a variable. So I can have address equals Colton, and then I can go ahead and print out the address right here, and we'll still get 1234 fun. Right? Well, Go, like I said, has this idiom where this access right here returns to us a tuple, and it's the OK, and it's a value and then an OK return to say if there is a value that exists there. So I can do OK address and OK, and so we'll print out both here to see what it looks like. So I do a go run and I get the address printed back out to me here, and then OK is set to true. So OK is a Boolean value, and it's set to represent whether or not the key exists in the map or not. So later on in your programs, you can say if OK, then you can work or do something with the address, like such as printing it out. So if I go and I remove that, Colton does exist, so 1234 fun is going to get printed to the console. But if I change this just to a C, which that key does not exist in the map, nothing will get printed to the screen. This can help you avoid doing a check of saying if address is equal to the 0 value of the value's data type in the map. But you may be wondering, how can I tell the difference between the 0 value if the key exists in the map with the 0 value, and then if the key does not exist, because maps still return to you the 0 value if the key does not exist. So that's where the primary use of the OK idiom works. So let's take a look at this. I'm going to change my address up in the map to an empty string, and then I'll change this assignment down here back to Colton, and then have an address one and an OK one. Copy this statement, changes to a 2 for both variables, and then changes to maybe some random string because we don't have that key in the map. And like I was saying earlier, if I went to go access Colton in the map, I would get the 0 value for the string, which is an empty string, but that is the same exact value that I would get for this key access right below it. But by using the OK idiom, we can see how these two values are different. So let's add some printf statements here. So I'll have address 1 is equal to a %s, and then OK1 is equal to a %t to print out the value of a Boolean. Put in address 1 and OK1, copy this statement to put in 2s everywhere, and now let's go ahead and run the program. So I do a go run, and we get for the access for Colton, that is an empty string, so we see nothing here after the equal sign, and then OK1 is set to true, meaning that yes, this key exists in the map, but it has the empty string or the 0 value. And then for address 2, again, we get that empty string because it does not exist in the map. And since it does not exist in the map, OK2 is equal to false. Now, what if you want to remove values from your map? Well, Go makes this super simple. Let's remove all of these statements right here, and let's change this to 123 fun way once again. So I'll have a format.println statement that will print out our address book. And if we want to delete a value from our map, all we have to do is call the built-in delete function in Go. So it's just delete. You pass in the map that you want to delete from, and then the key that should be deleted and its subsequent value that will be deleted alongside with it. So I would delete Colton from this. So let's print out this map again right after the delete. Save this, go down to the terminal, and let's clear it, and now run it once more. And we get, right after we initialize the map, that we had Colton put in here, and then after the deletion, Colton no longer exists in the map. In the same vein of this, what if we had multiple values that we needed to delete, or really want to delete the all the key value pairs in a map? So let's go ahead and add Emily into this, and just a random string. Instead of having to call delete for both Colton and Emily, Go luckily has another built-in function called clear. So you just call clear, and now you don't have to pass in any kind of key because you're going to delete all the keys in the map. So let's save this. We do a go run. We see that yes, Colton and Emily are both in the map, but then after clearance, there is no key value pair within the map. If you want to see how many key value pairs are in a map, you can use the length function just like you can with arrays and slices. So here we'll wrap length around this, and then we'll see after clearing it that it'll go to 0. So let's run this, and we get that at the beginning. Once this is initialized, it has a length of 2. After clearing it, it goes to 0. Last but not least, let's go over equality in maps. So if I have two address books, which are maps, so I'll do address book 1 and address book 2, we can use the maps package, just like slices have a slices package over in Go, maps also have a package. So we can call the maps package dot equal and then pass in address book 1 and address book 2. So since these were literally just copied from one another, let's run this. We're obviously going to get true printed out, but if I take away this one F down in address book 2 and Emily's value, we'll get a false is printed to the screen. And then if we just remove Emily entirely from address book 2, we will also get false printed to the screen. And that's it for the video. Thank you so much for watching. By now you should be an expert in maps, but I'll also go ahead and link the maps package over in the video's description so you can go check out all the extra functions that they provide for you to use. So if you learned something in this video, I encourage that you like and subscribe, and I'll see you in the next one.